Okay, here goes another three-letter theorem. So the next three letters I'm going to give to you is, excuse me, a theorem that we're going to add on to the other three amigos, so to speak. It's called the no-choice theorem. It's based on the no-choice theorem. So let's first of all focus on this idea. If two angles of a triangle are congruent to two angles in another triangle, then the third pair are also congruent to each other. It should be kind of obvious. Let's look at a diagram, though, for that, okay? If I know that these two triangles have congruent angles, and they don't need to be the same size, okay? So note angle A and angle B, angle C and angle D. Because these three angles and these three angles have to add up to 180, then there's only so much left over for this third angle. So put it another way, measure of angle A plus C plus X has to be 180, and B plus D plus Y has to be 180. And I know that these here are all congruent. So I could subtract A and B and C and D because they're the same. Then I know that we wouldn't have 180 any longer, right? But these two guys here, there'd only be so much left over, and it'd have to be the same amount, okay? So the no-choice theorem brings us to angle-side theorem. It is the fifth and final triangle congruence. And the idea is this. Given that we know that BA and DE are congruent, and angle B and angle E, I can still get these two triangles to be congruent. Now initially, hopefully you see the vertical angles. But as we talked about in the past, this does not have what we call an included side, congruent to an included side. So we can't use angle, side angle. But now that we have no choice, I can get that third angle to be congruent to that third angle. And now I have angle, angle, side, side, and then an angle. All right, so let's spell that out. So line one, line one, I'm given the following information. BA and DE are congruent to each other. And the measure of angle B, what would you say? Angle B is congruent to angle E. Then we know angle 1 and 2 are congruent. Again, let's label those angles, and that would be according to the vertical angle theorem. Then by no choice theorem, we would know that angle A and D are congruent. So therefore, triangle ABC is congruent to triangle DEC. And this is by angle, side, angle theorem. All right? So they'll give you problems where you have to conclude this is a proof, and if you've got to prove angle G and J are congruent, notice I've got two right angles. Again, we'd have to state that they're right angles. I know I've got the vertical. So this is a pretty simple proof. Not going to go through it. Your favorite, this could be kind of like a restrictions problem. In this case, we can actually solve. So we know by the exterior angle theorem that this guy here, which is sitting on the outside, is congruent to the sum of those two. So I'm going to say 3x minus 5 is equal to the sum. Solving that, we get x plus 65. Sorting things out, we get 2x is equal to 70. So x is 35, not 37. So to find the measure of angle 1, which is here, we would take 3 times 35 minus 5, which I think is 105 minus 5, which is 100. And then we would take 180 minus 100, which is 80. So the measure of angle 1 is 80 degrees. All right? Well, good luck with using AAS and the no choice theorem in doing the problems in 7.2.